This lab is the process of creating several serial dilutions to learn how to use the spectrophotometer. When beginning the process for starting the spectrophotometer, you will first need to zero your blank, which in this case is a water-ammonia mixture. First, clean off the two parallel sides of the cuvette with one cuvette wipe before placing it into the spectrophotometer. Open the spectrophotometer and place the cuvette into the spectrophotometer with the two clean sides facing where the light will go through the cuvette. After this, make sure to close the lid to the spectrophotometer before beginning the process to zero the blank. In order to zero the blank and to get the data of the absorbance rate for the rest of the samples, use the program scan. The blank is a cuvette which contains everything that is in the sample cuvette except the one material whose absorbance is being measured. This is important because all substances absorb light, and in order to measure the absorbance of the material we want, one must zero the blank, which essentially subtracts out the absorbance due to the cuvette. To set up the program, select Setup and then choose the option Fastest. After this, go to the farthest right tab in Setup, which is Auto Storage, and select Storage Off. To zero the blank, press 0, and after this, select the Start button. Once you do this, select OK for Sample 1. A graph should then appear once you have zeroed the blank. In order to get the absorbance value for each dilution, repeat the process of cleaning off two parallel sides of the cuvette with one cuvette wipe before placing it into the spectrophotometer. Open the spectrophotometer and place the cuvette into the spectrophotometer with the two clean sides facing where the light will go through the cuvette. Make sure to close the lid to the spectrophotometer. Then press the Start button on the program scan to receive the data. You will then see a graph appear. After getting the data, make sure to write it down in a chart in order to be able to use the data at a later time. Remember to get your cuvette out of the spectrophotometer before doing the reading process again. Remember to repeat this process for each one of your dilutions. Quantitative data is a numerical value measurement, while qualitative data is information about qualities that cannot actually be measured. The overall scan is like the qualitative data because it gives you a spectrum as seen by the graph, while doing a specific scan by choosing a specific wavelength is quantitative because there's a specific value for absorbance at that wavelength. A chemist must perform a scan across all wavelengths to select the one that absorbs the best, which occurs at the lambda max. The lambda max is a wavelength in the absorption spectrum where the absorbance is maximum. Generally, molecules absorb in a wavelength range centered around the lambda max, and it acts as a single quantitative parameter to compare the absorption range of different molecules. The Beer-Lambert law, otherwise known as Beer's law, is the linear relationship between absorbance and concentration of an absorbing species. When working in concentration units of molarity, Beer's law is written as the equation above, where A is the measured absorbance, E is the wavelength dependent molar absorptivity coefficients with the units shown above, B is the path length, and C is the analyte concentration. Each variable can be determined by plugging in the known values into the above equation and by algebraically solving for the unknown value. After finishing using the spectrophotometer, make sure to clean up your lab station by wiping down the counter and picking up all of your supplies. Also, don't forget to clean up within the lab, including washing out the beakers and disposing of the chemicals in the proper place. Make sure to place all of your supplies where they belong, and also don't forget to wipe down the countertops and to clean up your space before leaving the lab.